Alright, grade 9s, welcome back to lesson 6.2, which is solving equations using balance strategies. So we're just going to reiterate what our learning goal is. It's still the same as 6.1. So I will model and solve linear equations. The I can success criteria would be that I can model a linear equation. This time we're going to get a little bit more in depth with that. We can still verify our solution with substitution. We will go over that briefly again. And especially for this part here, we can solve a linear equation symbolically and pictorially, and then also that you can record your steps, show your work. So there's 3 ways on how we can solve equations using balance strategies. Here they are. So the first is modeling equations with variables on both sides, using algebra tiles to solve an equation, and then solving equations with rational coefficients. First off, modeling equations with variables on both sides. So you have to remember that an equation can be viewed as a balanced scale whose tipping point is the equal sign. Okay, so right here, this is the equal sign. So we have 3x plus 2 equals 2x plus 5. Well, very easily, you could remove these 2 blocks here. You could remove those 2 blocks there. So we have 1x, or x, plus 2 equals 5. So something plus 2 equals 5. Okay, so I can see that, well, x obviously has to equal 3. Therefore, you've just modeled an equation with variables on both sides. So voila here, and on the right side, and then you can solve that. Okay, so using this picture, using the scale, you can solve a model of a linear equation where variables, x and x, are on the left side and on the right side. So that's how we can solve using pictorial option. Now, solving equations with variables on both sides symbolically is done very similarly. You just have to be able to put the variables to one side. And as a math teacher, I like to put my variables, okay, to the left, Just to reiterate, where do I like my variables? I like my variables on the left side of the equation. Okay, so what essentially I'm saying is I want to get m onto the left side. So where I have here, I have negative 3m. So keep in mind, last unit or last section was solving linear equations using inverse operations. So the opposite of negative 3m, or subtract 3m would be the operator, would be to add 3m to both sides. So I can add 3m to both sides, leaving me with 5m plus 2 equals negative 8. Alright, and so now what I have to do here is I have to get this 2 over on the other side, so I'm going to subtract 2 from both the left and the right, because this equal sign is just like that scale was before. So I have 5m equals negative 10. And if I were to show this part here, I know my other lines were the kind of step lines. So like this was step 1, this was step 2. This is just the divide by 5. That way this crosses out, and I'm left with m equals negative 2. Okay, so there's my first, second, third, and then eventually I simplify here. You always want to get m by itself. We always isolate for that variable. Whatever letter it is, we always want just that variable. I don't want to know what 5m equals negative 10. We will always, as teachers, want to figure out, well, what does 1m equal? I know that a pack of apples might equal $5.99, but I want to figure out what's the cost per apple. To relate this to real life, you might go into a grocery store, and there might be a bulk option where you might find, oh, there's a bunch of things for $5, or individually might see something for $3 or $2, but depending on your needs, you can justify either case. So it's good to be able to do that type of math, and you do actually see that out in the real world, but we often don't really think about it mathematically like that. So let's take a look at our next example. So we have 4x minus 5 equals 2x plus 4. So I like my variables to the left, so I'm going to subtract 2x over here. And if you want to be keen, see right here I did one step where I just added the variable, or I subtracted the variables. You could also add 5 at the same time if you want to. There's a higher probability you will make a mistake, but you can do this as one operation. Okay, it's really important to put your answers maybe down below this question. Don't put them up top; it'll actually be incorrect because it will look like it is an exponent. So we've got rid of the 2x, take away 2x, that's gone. And now I have 4 plus 5, so that's 9. So 2x equals 9. So mathematically I have to divide both sides by 2. So x will equal 9 over 2, or I could say 4.5. Or if you would like to use decimals, that is okay with me, not a stickler. Okay, so 4.5 or 4.5. Let's try this one again. If you want to pause this right now so that you can check your answers on how to do 3 and 4, that'd be good. I'm going to do them here in 3, 2, 1. Okay, so here are my answers for numbers 3 and 4. So just a key thing, so get your variables on the left-hand side. You can get them on the right-hand side. It's just most teachers prefer them on the left-hand side. But really, if you had n equals 3 or 3 equals n, you are still correct. So you really have a preference of whatever you want to use. Just be careful when you are dividing by negatives. Okay, that's really the only thing. So if you want to take a look at numbers 5 and 6, we have to do a distributive property here. It's much easier to multiply 2x plus 2 by 3 than to divide the other side by 3, or divide this side here by 2. If you were to do that, it would be much more complicated. So we'll go through question 5 here, and then we'll get you to pause it and try question 6 on your own. So for 3, we're going to multiply this in with the 2x. So 3 times 2x is 6x. 3 also gets multiplied with the plus 2, so this sign's just going to carry down here, so we're going to have positive. 3 times 2 is 6. Likewise on the other side, 2 times x is 2x, and then 2 times negative 5 is negative 10, and now they're just like these ones. So now I can go ahead, I can subtract 6. If you wanted to get the variables first, that's fine. I'm just showing you another way to do it. So now we have 6x equals 2x minus 16. Pretty sure you see where this is going. Oops, minus 16, minus 6x. Minus 16. There we go. And now we're going to isolate. We're going to get our variables to the left-hand side. And oftentimes you'll hear me referring to isolate for x. It's another word for get x by itself. Isolate just means get alone. Okay, or alone. So we have 4x equals negative 16. We know that 4, we can divide that because x is being multiplied by 4. We have to do the opposite, inverse operation here. So those cross out. We're going to get x equals negative 16 divided by 4. is -4. Okay, and you can do the left hand or the right hand side here. I just want to reiterate. Finish question 6. X does equal -2. However, in this case here, I'm not getting full points. If I just refer back to the learning goals really quick, I need to record and show all my steps. This is really key. Without this, not getting a 4. So I didn't really show my steps here. I did show that I had distributive property. Clearly, it's kind of easy to tell that 2 times -2 will give you -4, but at the same time, I need to show it, or I'm going to assume you don't know it. Alright, so using algebra tiles here quickly. So I have 3m plus 7 right here. I have 2m subtract 8 on the right side. What I can do here by modeling is I can actually remove this, remove that, if I remove 2 of these. So essentially I'm left with 1m plus 7 equals -8, because I got rid of those 2m. Now, I want to be able to solve for m. So what I would have to do is I would have to subtract 7. Well, how could I do that? What I could do is I could actually add -7 to the left side. But if I did that, I would also have to add it to the right. So therefore, these all cancel each other out. So I'm solely just left with the rectangle for m, and that would equal this amount here, which is -15. Okay? So algebraically, I could show it one more way here, or another way would be, so instead of, so 3m plus 7 equals 2m minus 8, I could subtract my 2m, subtract my 2m, and then I'm left with m plus 7, just like I was, 4 equals -8, subtract 7 from both sides, therefore m equals -15. Negative plus a negative, it's just 8 plus 7, I'm keeping the sign the same, it's negative. Okay, for part 2 of this video, we're going to talk about solving equations with rational coefficients. I need more time than just my 15-minute regular allotment to explain that, so we'll do a quick part 2 video. Won't be as long as the other topics here. All right, so we'll see you for part 2 in 3, 2, 1.